Hello everyone, this is question number 24th from limits and derivatives for class 11th. So fx is equal to x square minus 1 for x less than equal to 1 minus x square minus 1 for x greater than 1. So they are asking to find limit x is tending to 1 fx. Okay, to solve it, because this function has two definitions, one for less than and one for greater than, so we will have to find LHL and RHL. So how to do it? We have to find LHL separate and RHL separate. So see here, LHL and RHL means if 1 is here, so LHL means 1 minus, okay, and RHL means 1 plus, means little bit more than 1. So how we represent is limit x is tending to 1 minus. This is LHL, that is how we show LHL. And here x is tending to 1 plus fx. This is RHL. Okay. So 1 minus means very close to 1 but less than 1. So which definition we should take? Less than 1. First or second? We should take first one, less than 1. Okay. So it will be limit x is going to 1 minus the first one, x square minus 1. Now just put the value of 1 only. So 1 square minus 1 is 0. This is LHL. Now RHL देखिए, limit x is tending to 1 plus, little bit more than 1. Little bit more than 1 means this one we will take, this one. So let me put it minus x square minus 1. So now let me put 1 here and check the answer. Minus of 1 square minus 1, which is minus 1 minus 1 is minus 1 minus 1 is minus 2. So you can see here LHL is 0 where RHL is 2. So can we say that LHL is not equal to RHL? So that's why limit will not exist. This is the answer. Okay, next question. Here question number 25. It says fx has two definitions. Means when x is not equal to 0, it is mod of x by x. When x is 0, the value is x. So whenever there are two definitions of the function, to find a limit, we have to find LHL and RHL separate. So we will do LHL and RHL. Okay. So what is LHL? Is 0 minus. This is LHL. And what is RHL? This is RHL. Means little bit more than 0. So LHL is written like this, is tending to 0 minus of fx, and RHL is limit tending to 0 plus of fx. Okay. Now let's write down. When it is 0 minus means very close to 0 but not equal to 0. Not equal to 0. So which one we will take? First or second? 0 minus means close to 0 but not 0. Less than 0. Less than 0 we will take first one. So it is limit going to 0 minus mod of x plus by x. Okay. Now directly we will put 0 and get the answer. So here you put mod of 0 by 0 is 0 by 0. In limits, 0 by 0 is never accepted. So we will discard it. This is not accepted. Now which method we should apply? Whenever we end up having 0 by 0 method, either we use formula or we simplify. Here there is no scope of formula or simplify, so we will apply H method. See carefully what is H method. In H method, the limit is going, H becomes, H is tending to 0 and x is replaced by 0 minus h. This is what we do in h method. Clear? Why 0 minus h? Because it is little bit less than 0. That's why. H is some hypothetical number which is very very tiny number. Maybe this much. Very very small hypothetical number. It is just helps us to calculate the limits. So this is how we will solve it. So it will become limit h is tending to 0. Then what will happen? X is replaced by 0 minus h by 0 minus h. Okay, what is the next step? We will first get rid of mod. So limit h is going to 0. Whenever we have to remove mod, the minus h will become h only. And now down is only minus h because there is no mod. H and h cancel. So I am getting limit h is going to 0. 1 by minus 1. So it is minus 1. We don't have to put any h because h got cancelled. So this is the left hand limit. Okay. Now right hand limit. This was left hand, right hand limit. See here, it is 0 plus. 0 plus means not 0, next to 0. Very close to 0, but not 0. So which one we will take? This or this? Not equal to 0? The first one. So limit going to 0 plus mod of x by x. Now try to put 0 and solve it. Mod of 0 by 0 is 0 by 0. 0 by 0 is not a valid answer. Correct? So let's discard it. And we will use h method. What to do in h method? The limit changes to h tending to 0, and x is replaced by 0 plus h. Why 0 plus h? Because it is little bit more than 0. So this is what we will do here for h method. Okay. So limit h is tending to 0. X is replaced by 0 plus h by 0 plus h. Fine. So now this will become limit h is tending to 0. When we remove mod from here, it will become h by h. H and h cancel, which is 1. So limit h is tending to 0, 1 is 1 only. So we can see these two are different. One is minus 1 and one is plus 1. Both limit values are different. LHL is not equal to RHL. So can we say limit will not exist? Correct? Now question number 27. So you have to find limit x is going to 5 where fx is this. So fx does not have any two definitions, means it is not changing. So we don't have to find LHL or RHL, we can solve directly. So limit x is tending to 5 f of x, correct? No need to find LHL or RHL because there is just one definition of fx. There are not 2-3 definitions. 5 mod of this. Directly put 5 and get the answer. Mod of 5 minus 5. Mod of 5 is how much? 5 only, which is 0. And 0 is a proper answer. If 0 by 0 is the answer, then it's a problem. But now this is accepted. This is question 28th. So here fx has 3 different definitions. First definition when x is less than 1. Second when x is 1. Third when x is more than 1. Correct? So when there are multiple definitions, Then to solve question, we should always use left hand limit and right hand limit method. So they have given x is tending to 1, function fx is equal to f1. They have given. Using this, we have to find a and b. Correct? So let me first find out the left hand limit, right hand limit, and the function value. Correct? So there are three things that we should know here. So let me do LHL and then RHL. LHL means what? Means 1k little bit left, which is LHL side. Okay, and right hand side is RHL. So how to donate it? How to write it? X is tending to 1 minus of fx. That's how we write LHL. Fine. This is LHL. Let me remove it. LHL. So, little bit less than 1. So which one should I take? This or this? Which one? Little bit less than. So little bit less than means this one we will take. So it will be limit of x is tending to 1 minus a plus bx. Now we will just put 1 in the question. See, 1 minus is just a fancy notation to show that x is almost 1. Not exactly 1, but almost 1. Approaching from left hand side. To solve it, we have to put x is equal to 1 directly. To put it there, a plus b into 1 is a plus b. So this is left hand limit. Now right hand limit, 1 plus fx. Write down. This is the notation. Okay? 1 plus fx. Now we will choose which fx. First one, second one, or third one. Which fx? See, 1 plus means more than 1. So which one we will take? This one, the third one, which is more than 1. So this will be limit x is going to 1 plus b minus ax. Now directly put 1. So what we will get is b minus a into 1, which is b minus a. Okay, so this is LHL and RHL. Now what is f1? See, they are saying limit is existing and it is equal to f1. Otherwise they would have told limit will not exist. If they are telling that limit value is f1, that means limit exists. That means we can say that a plus b is equal to b minus a. This is first equation. Correct? Now what is f1? f1 is given here. When x is 1, f is 4. So f1 is 4. So what equation we will get from here? From the limit is f1. So that means clearly they are saying a plus b is also 4. b minus a is also 4. And these two are also equal. A plus b is equal to b minus a. So from here we are getting some absurd equation. Means b and b cancel, a is equal to minus a, which is not possible. So we will ignore it. Okay. Now let me see. These two are equations. Let's try to solve it. Okay, how to solve it? Let me write it. A plus b is 4. B minus a is 4. Let me solve it. So I will get, when we add, this is cancelling. 2b is 8. So b is 4. If b is 4, let me put it in first equation. A plus b is 4. So a plus 4 is 4. So that means a is 0. So this is our answer. B is 4 and A is 0. This is our answers in order to satisfy the given condition, which was saying that limit x is tending to 1 of fx is f1. That means they are saying limit is existing and which is equal to f1. That is what we did. That's why we did LHL, RHL, both are equal to f1. Okay, I hope you understood. So this is, here we got LHL which is equal to f1. Here we got LHL which is also equal to f1, and then we solved it. That's it. This is question number 29. So they have given fx. Please write down. They have given fx. This is fx given. X minus a1, x minus a2 and so on till x minus an. So they are asking to find limit x is tending to a1 and limit x is tending to a. So because there is only one definition, so no need to find LHL or RHL. Directly we will put and get the answer. So first part I am doing, x is a1 fx. What is fx? X minus a1 and x minus an. ठीक है. Now we will just put the value directly because we will check the answer. a1 minus a1, a1 minus a2, a1 minus an. So see here, a1 cancel, which is nothing but 0. So 0 into a1 minus a2 and a1 minus an. So final answer is 0 because 0 into anything is 0. So this is done. First part is done. Second part देखिए, we have to find limit x is tending to a f of x. What is fx? Fx is this. So I will put it here, limit tending to a x minus a1, x minus a2, x minus an. Fine. अब क्या करें बोलिए. See, there is only one definition of fx. No need to do LHL, RHL. Directly we will put x here and get the answer. ठीक है? I hope it's clear. Directly let me put a. See, wherever x is there, x is equal to a I will put. Write down, put x is equal to a. So x minus a1, फिर a minus a2, correct? X is a here. A minus a2 up to a minus an. And this is only answer because a minus a1, a minus a2, then a minus a3 and so on up to a minus an. So this is my final answer. You have to try on your own. This is question number 30. They have given 3 definitions of fx. So fx is different when x is less than 0. Fx is different when x is equal to 0. And it is different when it is x is more than 0. So they are saying that this exists, x tending to a, find a. Correct. So a is unknown, but they are saying limit exists. For what values of a the limit will exist, and we don't know a. So there are 3 possibilities that a is maybe a positive integer, it may be a negative integer, and it may be 0 itself, right? Because function is defined before and after 0 and at 0. So a may be positive integer, negative integer or 0, or it may be non-integer as well. But we will try on these 3 and see what is the possible value of a for which it will exist. Okay, any positive integer we can take example here, say plus 5. Negative integer we can take example, say minus 5. and a is 0 in third case. So we will check the limit on all three cases. Fine. So that's how we will start checking. So let me try first the easiest one, which is 0. तो लिखिए let a is 0. So we will check at 0 LHL and RHL. So LHL and RHL. Yeah. So we are checking on 0. So it has to be 0 minus and 0 plus. X is tending to 0 minus and 0 plus. Correct. Fine. 0 minus means little bit less than 0. So which one should I take? Less than 0. This one, the first one. In RHL, little bit more than 0. Right? By now you know. See, if this is 0, 0 minus means this side and 0 plus means this side. More than 0. So for more than 0, I will take this. So let me write down. Limit x is tending to 0 minus. I will take this. And for 0 plus, I will take this. Okay? Yes. Now let's start solution. So this is 0 minus. So I will put 0 and try to solve. So mod of 0 plus 1. Usually for mods we use H method. Always try to use H method. So write down H method. It's better to use H method for mod for questions. So H method में what we will do? H is going to 0 and x is replaced by 0 minus h. H is some tiny number. Okay. So this is called H method. So I will imply here H method. Limit, ध्यान से देखिए, in H method limit changes to 0. H is going to 0 mod of 0 minus h plus 1. Correct? Right? So let me put here limit h tending to 0. Can we remove mod? 0 minus h. It will be h plus 1 only. Remove it. Correct? H is some tiny number. Some negative tiny number minus h. Right? Say h is say 0.01. So when it is minus h, minus we will remove to come out of mod. Right? So it is h plus 1. Now put h 0 plus 1 is 1. So this is left hand limit. Fine. Now we will do right hand limit. RHL side also we will apply H method. Because whenever there is a mod question, it's better to apply H method. So in H method, limit will change to h is tending to 0 and x will be replaced by 0 plus h. Okay, here it was 0 minus h, here it is 0 plus h. Fine. So let me do it. Limit going to 0 plus h minus 1. Fine. Limit, how to remove mod? 0 plus h, so it will be h only. Perfect. Because when we remove mod, only the number comes out, the sign disappears. So h minus 1. Now put h 0. 0 minus 1. We are getting minus 1. Here LHL was 1. RHL is minus 1. Is not equal to RHL. for for a is equal to 0, because we started assumption that a is 0. For a is equal to 0, write down limit will not exist. So they were asking what is a for which it will exist. We are sure for 0 it will not exist. Now let some other number, say a is 5, some positive integer. We are just assuming some positive integer. Okay, so let's try for 5. LHL and RHL. Limit x is going to 5 minus for LHL and 5 plus, correct? So 5 minus means little bit less than 5. Little bit less than 5 will be what in this question? Little bit less than 5 will be less than 0 or more than 0? It will be more than 0 only, correct? So I will take this mod of x minus 1. Now we can apply H method, correct? What is H method? H is tending to 0 and x is replaced by 5 minus h, correct? Okay, so it is limit h is tending to 0, 5 minus h minus 1. How to remove mod? Limit h is tending to 0, 5 minus h will be some positive number only. Why? Because h is a very tiny number. So 5 minus a tiny number is a positive number itself, right? So we can just remove mod. So 5 minus h minus 1. Now put h is equal to 0. So 5 minus 1, which is 4. So this is left hand limit 4. Correct? Because we kept h is equal to 0. So 5 minus 1 is 4. Now right hand side देखिए, 5 plus x is little bit more than 5. So which one should I take out of these? This or this or this? Little bit more than 5 will be more than 0 only. So I will take this, right? Let me write down here. Mod of x minus 1. Now we will apply H method. So for H method, what do we do? H is tending to 0 and x is going to 5 plus h. ध्यान रखिए plus because it is RHL. This is H method. So limit h is going to 0, 5 plus h minus 1. Okay. Just little bit more to go. Put h is equal to 0 और या फिर remove mod. So 5 plus h, the mod will disappear directly because 5 plus h is a positive number. The mod will disappear. Now put h is 0. So 5 plus 0 minus 1. What is 5 minus 1 is 4. 5 minus 1 is 4. Clearly LHL and RHL are equal. So write down LHL is equal to RHL for a is equal to 5. So that means for any a equal to positive integer, limit will exist. Why? Because you have taken 5. If you take 6, then also it will come. you can try with 7. For all positive integers, limit will exist. Okay. Now we can take a, say, some negative integer. For this, if you try, you try the same way LHL and RHL, you will get same. So that means limit will exist. You can try on your own. Limit will exist for negative integers as well. So that means what is A? So that means A can be any number. It can be any number except A is equal to 0. Because we saw in the beginning of the question when A was 0, limit was not existing. LHL and RHL were not equal. But for positive integers, for negative integers, limits is existing. So that means A can be any number except 0. Matlab limit will exist for everywhere except it will not exist at 0. See you in next video. Bye everyone.